Hi, everyone. My name is Yishai. I'm from LinRB, and I'm going to talk about DevOps 2.0, or what I like to call the path to continuous merge, how to make developers happy. So I'm going to have three parts to my talk today. Going to shine a light into what we see around CICD and the gaps where a lot has been solved, a lot of progress was made, but highlighting some pains in that process. I'm going to dive a little into pull requests, some data analysis, some research that we've done around this, and then basically start to think about solutions for those pains, highlighting how they would look like. So very brief history for software development. Some of us remember the days of waterfall, where you were lucky if you got something out every year or every few months. You print a huge Gantt chart, you stick it on the wall, it gets obsolete the day after. Then came Agile, and there's a lot of scripture and lore and holy wars and like dogmas around what Agile means and how to do it correctly. But in the essence, the ability to iterate, to ship software faster, by making incremental change by iterations, is I think the essence of what Agile brought us. And then DevOps, a bunch of buzzwords, DevOps, then SRE, now platform engineering. A lot of changes happening, both because we have cloud and now you don't have to actually ship pizza boxes to places. You can quickly create servers, VMs, containers. You can test your code. You can create a developer environment. Everything is much faster. And now you have the ability to run full-blown test suites to check every aspect of your system before you ship it. We have unit tests, we have integration tests, everything that lets us ship even faster with more confidence because we have a great security net that helps us avoid shipping bad code. So if you look at the CICD, typically the typical cycle for developers to get value out of the door is to code it, then have some review process, get it merged to the code base. Eventually it gets integrated, built, tests, and so on, and deployed. Obviously this is oversimplified, but a lot of how developer teams produce value looks like this. And you have CI, which is around building, testing, verifying everything before we ship it, and then CD, which is how we actually deploy it to the right systems, the right staging production environments. But if you look at the delays and frustrations, you see that there's a lot of time spent and a lot of frustration happening around the code review and how to get my code merged. What does it take? Eventually, tests are automatic. They run. They take seconds or minutes, sometimes hours, but it's typically a machine. It's code. It runs. You can put some more dollars on it and it will run faster. But getting my code merged, getting my code reviewed is humans, right? Someone else has to make time for it, stop what they're doing. There's some ping pong. There may be some sensitivities around the process of giving feedback and accepting feedback. We've all seen snarky PR comments or people that will do anything to avoid this person reviewing their code. And this adds up. This is a lot of time. This is a lot of time where developers have to wait for others to get their code across the finish line. So that is one key area where things are stuck. And I want to highlight the fact that a lot of this is about humans, not about code or machines. And then another area where frustration is building is that machinery, the CI/CD part, where, okay, it works for me. And then CI takes too long. The build is long. I have to wait. If it's more than just a few minutes, now it's like a full-blown context switch for me. So I'm going to go and grab a coffee, or I'm maybe do some emails, or handle a Slack thread. I've already zoned out of my original intent. And if it's a simple thing, but it takes 15 minutes for my test to fail because I forgot a stupid thing in my code, now I'm paying the cost of that context switch. And then flaky test. Who here has never seen a flaky test or never suffered from that? So you've never, okay? Lucky you. So when developers on the team get used to, let's just try it again. This like the old Windows restart solution. Let's just try it again. Maybe it'll work. When you know you have a problem, and we are all developers. We know it doesn't make sense, right? This should work. If it failed once, it should fail forever. And if it's passing the second time, it should have passed it the first time. And then after I finally got everything to pass, the code base has already moved. Someone else made it before me. Everything starts again. And eventually, I'm done. I finished deploying my code. I'm done with or merging my code. I've done my part. I can move on, and now I'm happy again. So, two major pains. One is around the human process to get my code reviewed and ready to merge, and then a little more machine process to get my code to pass everything that's needed and to be ready for merge and or deploy. And I want to dig into some data and research around pull requests, because these are the vehicles where most of the developers push their code through both of these hoops, the review and the testing. So looking at a bunch of pull requests from and reviews from a lot of data that we see. One very obvious, but and sometimes alarming data point is that PRs are idle. Most of the time they're just sitting there with no one working on them. No one, meaning the issuer has already moved on to something else. There's no one reviewing them right now. They've been switched out from everyone's minds. And 50% are idle for 50% of the time. And this is just work time, not nights, not weekends. During the workday, the PRs are just sitting. They're waiting for someone to switch back to work on them. And a third of them are like idle for 80% of their lifespan. So things are not moving. Things are waiting for people, waiting for attention. And the main impact of this is that there's a lot of PRs in the air. There's a lot of work in progress or risk in progress, and there's a lot of context switching. We found that once PR crossed a single day, they had to wait overnight. Now they're going to wait even longer. So again, if a PR doesn't get handled quickly, it's going to suffer even longer waits. So one tip: can you get your PR to be picked up and reviewed within the hour, and fitted within that 1 day cycle is a huge win. So if we look at those two pains and the kind of data that we're seeing around PRs, what's missing? What can we think about? What's causing these pains? And I'm going to highlight 4 types of missing things. One, there's knowledge. Think about large teams. Think about new people coming onto teams. I don't always know how to get my PR reviewed and merged. Who is the person that I should call in here? Sometimes it's well known. Sometimes I have to hunt for the right person to review my code. What's the standard? What am I supposed to provide in the PR as context and so on to get this to be effective? In general, what's the best way to move forward? There's a lot of knowledge. There's a lot of unwritten lore. This is how we work. It's written. It's nowhere. It's in everyone's minds. Seniors know it, and they pass it in some fragmented way to juniors. So there's knowledge missing for developers to do the right thing. The other main piece is context. A reviewer needs to know what's going on with this PR. Why is it important? Which one should I do first? What's the impact? So what kind of changes this? Should I even start to look at it right now? Can this wait for later when I have time? How long is it going to take me? A lot of context is missing. And when we have good context, and I'm going to show some data, when we have good context, that shapes the behaviors of reviewers and lets them do the right thing. Remember, a PR reviewer typically has a different agenda, right? They're busy doing their own thing. And then another thing that's missing is that a lot of us are basically saying there's just one process for all code changes. All PRs are handled the same, like 4 eyes principle or something like that. There's almost no flexibility and no room for automation to make some smarter decisions. So can we remove some manual processes or checks from people? Can we change the way we review some of the PRs? Can we maybe skip reviews for very simple ones? Like, we just changed a static image in our web app. Does that really need a reviewer? Maybe not. Or maybe not the code reviewer. Maybe it's a UI person has to look at this. On the flip side, how do we enforce best practices? I just made a change that has a security impact. How do we make sure the security guy gets in and is part of the review process? Do I have to depend on the missing knowledge of the developer that, oh, this is a security change and this is the person I should pull in? So flexibility and automation. And finally, visibility. So you ask developers, they'll say, oh, the tests are flaky or they're taking too long. But do you have a way to measure that across the board? You have 1,000 repos. Where's the problem? Is it in one place? Is it in another place? What kind of changes trigger that flakiness? Or how do you know where to invest in solving those problems? So flaky tests, long tests, failures that don't create code changes, PRs that keep hitting, like a need to update the baseline and resolve conflicts. All of that, if you're not measuring it in some centralized way, you're blind or you're following very biased signals to try and solve these. So where do we invest, and is that even worth it? Is an investment of 3 months to cut our CI in half, is that worth it? What is it going to give us? I promised some evidence or data around how context influences reviewers. This is an example, but real data, of a piece of context that we call estimated review time. This is like a nice machine learning model that estimates how long you're going to spend reviewing this PR. So similar to what you have with estimated reading time for some articles on the web. And when we plug that piece of information together with the alert saying the reviewer, hey, you have a new PR to review, we tell them it's going to take you 2 minutes here at the bottom, or 45 to 60 minutes. When the reviewers get that signal, we measure how quickly do they pick up the PR and start reviewing it. That's the hours, pickup time. And it's not surprising that when I know this is a quick PR, a quick win, I'm going to jump on it, and the average pickup time is very small, very short. If it's long, as a reviewer, I'm doing the right thing, and I'm waiting for when I have more time, maybe scheduling time, and then the pickup jumps to 6 or 8 hours. So instead of clicking a link or like on an unknown PR, no context, seeing a big wall of red and green, saying, oh, I don't have time for this, or maybe I'll step back, maybe someone else will take a look first. All of that can be optimized with just providing context. So this is an example of real behavior changing because of context. I also want to talk about flexibility in the process. There's a model, one of many, but interesting to talk about, which is ship, show, ask. And this is basically saying, let's imagine 3 paths in which code can be reviewed or accepted into the code base. There's ship, which is basically I'm shipping my code. I don't have to ask anyone. There's like enough trust in the reviewers and in the tests that some changes in the code can just be merged. Then there's show, which is I'm merging it, but I'm letting people know. Maybe they can review it post-merge. They can maybe catch some problems or make some comments, but it's not a blocker for my merge. That is the show. And then the ask is what we typically do, which is get someone to review and approve, and then merge it. If you're able to classify your PRs to which needs to go where, it's the benefits are obvious. If I can just ship 10% of my PRs, I removed a load of waiting time and a load of review, and also pretty rubber stamp reviews, right? Those PRs are probably not going to get an interesting review. So I can save a lot of time and hassle for both the issuers of the PRs and the reviewers if I'm able to make those classifications. And if I have some machinery that lets me make the decision and actually implement the right workflow. So if we think about, okay, if we want to start solving these pains and we want to address the missing knowledge, context, flexibility, and visibility, how would we imagine such a solution for this? What would be the key ingredients? So, like, what should it be able to do? Where and how would it run? How do I scale this to support a big organization, not just one or two teams? And like initial ideas of things that this smart engine could do. So think about a pull request linter, right? We've all seen teams that implemented a check that blocks the PR if there's no JIRA ticket. If there's no description, if you haven't clicked the checkbox saying, I've actually tested it. A lot of teams like already implement homegrown solutions for parts of the problem, and I'm putting all that in the like a linter bucket, a lint for my pull request, not for my code. Do I have the right pieces in place? What about letting letting the reviewers know that they should start reviewing only after the tests have run and succeeded? How many times did you start reviewing a PR and you're seeing it's actually failing? It's not ready. So even that small optimization, don't mess with me until your PR is actually passing the tests. Or maybe let the developer decide. I want early review. This is draft, but I still want people coming in. Look at what I'm doing here, even though it's not the final diff. Maybe there's a way to prioritize. If I'm blocked on my CI, there's a queue. There's a special machine that needs to run the CI because it's, I don't know, hardware. Is there a way to get the urgent or important or, I don't know, executive sponsored PRs to get like in the front of the queue? All of these, can I prioritize instead of just having everything wait? Maybe prioritize a small, like it's a tiny PR that is quick to review. Maybe like let it skip the top of the line, because then it could, like, I can finish the test and deploy it, and it doesn't have to wait for that huge PR that needs 3 reviewers that are going to spend days reviewing it. And that's just an initial set of ideas. Looking at building blocks in such a solution. So context. I talked about context and why it's important. Again, remember, we have a lot of human interaction here, back and forth between humans, and humans need context to make good decisions. So examples of very well-known pieces of context in PRs. There's labels. I took a screenshot from, I think this is Node. Look at all these labels, right? This is a great way when there's a ton of PRs to understand what's important for me, or what kind of change is this, what is it touching, a lot of things, maybe what's missing. So labels are a great way to expose context in a very condensed form. There's obviously the comments, like people writing comments on the PRs, the title, the description, all of that is context about what I'm doing. There's badges, typically on repos, but sometimes you can also have them inside a PR saying, oh, the coverage went up, went down. A lot of, again, a very common way and a very, like, that people understand to convey context. And then there's the JIRA or the ticket. What am I doing here? What is it related to? Is this a bug fix? Is this a feature? All of that are all interesting examples of context. So any solution that tries to solve the pains I was talking about should be able to reason and handle and mangle context in a meaningful way. Another building block or first-class citizen is the review, right? A solution should be aware of the review process, should be able to find the best reviewer for the code, should be able to help with solving as a reviewer, what do I need to do? What is expected of me? What's the right process to review the code in this company or team? And then manipulations on the review, right? Can we control who should be reviewed, who's required, who's invited, what's the minimum number, what's the maximum number? All of these parameters of code review are useful to look at and maybe modify. So think about the 2-to-1 here. There's teams like in financial services and other regulated places where they have a 6i principle. There's two different people have to review the code. If they can, in some cases, move that to 1, so from 6 eyes to 4 eyes on some well-defined changes in the code, that's a huge gain. And there are companies that live like pay this tax all the time. So manipulating the decisions and boundaries of review are an important building block. And then obviously there's checks or tests or builds or whatever you want to call them. All the automated events happening for, typically in a PR before merge, sometimes also after. And then you want to first track the behavior, have some centralized sense of how long are they taking, how is that the difference between repos or different services, failures and successes. Again, track, if you have long tests that failed, it's a bad sign. Ideally, failures should be quick. And then, can we use some context and information to make decisions about which tests need to run? Do we have to run everything all the time? Or maybe the order in which I run things so that I can maybe fail faster? Can I be more dynamic about how I'm running those checks? And finally, take the output and use it to make some flexible flows. Typically, if a check fails, the PR cannot be merged, right? That's a very simple flow. If anything failed, or if a sonar said the code is smelly, I have 2 options. I can let it go, or I can fail the PR. What if we could be more flexible? What if we could say, oh, if sonar said something, pull in a security person to review the code. Make them required. But you're not failing the PR. You're giving someone a decision point. So you can do a lot of in-betweens if you have that flexibility. It's not just a 0 or 1 game and just rerun the check to be able to merge your PR. And obviously, as building blocks, you need to be able to action on the PRs. So things like reject the PR, maybe give a comment. If someone is touching deprecated code or making a call to a deprecated API, just request the change automatically. You've saved a review cycle. This is the automated review, and the issuer gets the notice, and they can fix it and try again. Or in other cases, if it's a simple change that you're feeling safe, just approve the PR. So skip the review process, make an automated approval. And for the brave, there's actually automatically merge it. And there are people that actually do this, like automated merge if everything is looking okay. Or on the flip side, it's not just reject with comments. It's just I'm going to just close the PR. Automatically close it because it's doing something that is not allowed or not wanted in this code base. And I talked about measurement, so tracking the events, track the handoffs, track the failures, make sure that this is tracked from the PR level to repos to services to the entire group or organization to let you eventually slice and dice everything and find out your bottlenecks or your problems in both the human process and the automated process. Finally, if we are thinking a bit forward and some more advanced considerations on what a solution would look like, so we want to make it dev-friendly. We want to let developers code their way out of the problem, which basically means this is programmable. Whatever we do, and I mentioned here various examples of what this could do, it has to be programmable. It has to be flexible so that, every team is different. Everyone is a snowflake. They need to be able to create the rules that match what they need or the regulation that they must meet. These things change between teams. They change over time. So it has to be programmable. It can't be just a fixed thing. And as we're developers, whatever we program, the rules, the configuration, everything, it has to be version controlled and treated as a part of my code, basically. So I'm thinking about something that would codify the process, codify the decisions, the additional context, everything is codified, and that manages version, like version controlled and so on. I think any other approach would probably be dead in the water. You need to think about scale, and not the performance side of things, but more like, how do we roll something or solve those pains in a large organization with hundreds of developers or more, where with both I can control my repo and my service and how that works, but I also have organizational controls or organizational capabilities that maybe want to enforce some uniformity across the board. For example, if we need a Jira ticket for every PR, that would be an organizational decision, and it should be enforced across the board with low effort. And then a specific repo can say, my rule is to allow automatic approval of PRs that only change CSS files, because what could happen? And then extensibility, whatever this solution looks like has to eventually talk with different systems, right? Do you want to send a Slack message to someone if something happened during the process? What if we don't use Slack? We use something else. So extensible in integrations with other systems. Obviously play nice with your neighbors in the pipeline, the systems that run the checks, and everything else is like automation or rule engine doesn't live in a vacuum. And eventually, you want to be able to extend it with custom code or plugins or some methods of applying like a little deeper logic and making those, providing more building blocks to that automation. And then, on one hand, every team is different. Every organization has different rules and different requirements. But if there's a community, if there's a way to share those ideas, hey, we have this is how we do things, or this is how we solved a problem around flaky tests or around required reviews, then you can start learning from your peers. You can share what's working for you, and maybe, hey, that's a great idea. Someone else has implemented a flow that I can find useful. So a community with sharing of ideas is another great way to have, or a great capability of that solution. If we put everything together, everything I talked about, we are imagining or thinking about like a programmable automation engine for pull requests that is a rule file or some other incarnation of that codification. It lives in my repo, so it's versioned. It runs in my pipeline or a pipeline. So GitHub Actions could be a good place to do it. It has to react to events on my PR, like the new commit or someone made a comment, or like those are typical, like natural events to react to and make decisions and changes on. And it should be able to decorate my PR, add labels, remove them, change the state, approve it, merge it, call someone into review, play with the limit of reviewers. All of these are actions that are like natural for that to affect the changes that I need. And it needs to somehow measure everything that's going on. Measure itself. This is the decision I made. This is the verdict I gave. Also measure the timing, like how long did things take? How long did the CI run? How long was it until someone actually reviewed the code? And all of these, and centralize that measurement so that we have observability of that process, of the whole process of getting code reviewed, tested, and successfully merged. And what I like to call this is a continuous merge. So if we had CICD, now we have another piece of automation, and it's a little different because it involves humans. It's not just something that you run and finishes, But now you can talk about continuous merge, which leads then into continuous integration and continuous deployment. So just like we've automated, the industry's automated a lot in testing and deployments. Now you can extend that to automate or semi-automate the merge process. Here's an example of how we approach this in LinRB. It's a very small snippet of a rule file. So rule file living in the repo that can make a decision. For example, you're touching a gateway file, call the security person to be a reviewer. That's an example of a snippet where eventually you make decisions based on context, and then you can add context, and then you can change the state of the PR. And you generalize that, you get a very powerful engine to basically do everything I talked about. We call that Gitstream, so feel free to take a look. This is our approach to solving this problem, and thank you.